Okay. For me to duck.
No, you're good.
We good to go? Say action.
Action.
Okay. Thank you everyone for coming. Can you all hear me okay?
Yes.
Brilliant. So this talk is going to make all your other issues seem minute in comparison. You're not going to worry about your job for the next half an hour, which is a positive. Probably one of the few positives. It's probably quite natural to feel any of these emotions, not purely because of the kind of jokes I might tell, but because of the information I'm going to be sending your way. So if you need to leave at any point, feel free. And also there are post-it notes and pens if you want to write down any questions, which we can discuss at the end.
I find that myself helpful.
Exactly.
Just,
You want to use a chair, is that lady? Oh.
there's no cheering, unfortunately. Well, there's a little bit of cheering at the end, but you have to wait for that. Okay, so I want to talk about me a little bit, but there isn't time, so I'll just say that I used to be big into the environment. I used to go on protests and stuff, but then I started working in Southern Water and made a reasonable amount of money, and I thought, nah, stuff it, I'm going to travel the world and go rock climbing and scuba diving. And then I was really depressed and I tried to buy a car just like this, and it didn't exist. I got scammed out for £5 grand, and it made me reassess everything and what I was doing for, and what kind of legacy I would leave after I died. And so I went to a talk much like this, and that got me thinking. Now, come on. This is where all the climate stuff starts. So this phenomenon has been known about for about 100 years. You've probably heard of it. The heat comes in, is trapped by naturally occurring greenhouse gases, and some of it's reflected back out again, some of it's trapped. Now, that's normal, and the plants and animals have evolved to thrive in that climate. What we've done, and we've known about this for about 80 years, is we've burnt a lot of stuff, and that produces more greenhouse gases, which provide more insulation and warm the climate overall, which isn't so great. So you can see from this lovely GIF, which is in Fahrenheit, everything else we're talking about is in Celsius, that the global average temperature is going up. It's only 1.1 degree that's gone up since pre-industrial levels, which doesn't sound very much, but if your core temperature goes up by 1 or 2 degrees, you're in trouble. If it goes up by 3 or 4, you're dead. That's a pretty good analogy, actually, because if the planet were to warm that much, and it looks like it would if we're not very careful, it's not going to leave much for children born today. So these guys are what we call the IPCC, the Intergovernmental Panel on Climate Change. They were set up in 1988 by the UN after about a decade of pressuring from scientists. They produce a report every 5 years, and occasionally special ones too. So a graph, just like a team meeting. You can see on average, this is over the past 800 years, CO2 levels are about here, about 300 parts per million. They certainly never went above 300 parts per million. At pre-industrial levels, they were around 278, and then this graph here starts in the 1960s, here at 310, and works its way up. So the first report that was produced was in the 1990s and said you probably want to keep the warming to 1 degree. That would be a good idea. And then there was a summit in Kyoto which set some binding targets which were missed, and back then it was kind of, if we do this, climate change won't be a problem. Now it's more of a case of, if we don't deal with this, then there won't be a future. And that sounds really extreme, but as I'll go on to explain, that is the reality, sadly. 2001, the US pulls out the Kyoto Agreement, which is rational if you're short-sighted and you don't, if you're short-sighted really, I don't want to be too bleak. A report is released that says prevention is better than cure, in 2006. No surprises there. It will be cheaper to prevent it than remedy it. And 2015, this is the most recent agreement, the Paris Climate Agreement. I think there are 190 odd countries that were involved, not including America. And they decided to set a target of 2 degrees. Now the IPCC, that Intergovernmental Panel, they strongly recommended 1.5. But to kind of balance the need for economic growth, 2 degrees was set. And then emissions continued to rise after that. Now, in October last year, the IPCC released a report that said we've got 12 years to cut emissions by 45% globally if we want to meet that 1.5 degree rise, which is pretty stark, and it was covered by a lot of press. But because we're busy people, we don't notice it. You know, we're caught up with other things and gadgets and whatnot. So we'd have to cut it by 45% in the next 12 years, and then go on to be net zero emissions by 2050. Here is a graph showing temperatures. So now this report assumes that warming is going to be linear and it's not going to happen any quicker, which is a bit of an issue really, because the science would suggest that actually it probably will happen quicker, that it won't be a linear increase. So I'll explain why that is. So here's a report from 1990. So this isn't a new idea, but it says temperature increases beyond 1 degree may elicit rapid, unpredictable and non-linear responses that could lead to extensive ecosystem damage. An absolute limit of 2 degrees can be viewed as an upper limit beyond which risks of grave danger to ecosystems and of non-linear responses are expected to increase rapidly. So we're the ball in this picture, and we've been warming slowly at this point, but as things start to increase, the warming will increase at speed. So I'll explain why that is. So, as you've probably heard, ice is melting. Here's a picture showing that. This was the Arctic in September of various years. And what that means is you have a feedback loop, one of many, but I'm only going to touch on a few. So, as the ice melts, you're removing, or a really reflective surface is disappearing, and it's being replaced by a really absorbent dark surface, the sun, the surface of the ocean. So it's going to absorb a lot more heat than it would have done. This is known as the albedo effect, and if you've ever worn a black t-shirt on a sunny day doing work in your garden, you've probably only done that once, because it makes a huge difference compared to wearing a white t-shirt. And it's a feedback loop, because the more ice that melts, the more heating occurs, which leads to more ice melting, and so on and so forth. Here is a picture from NASA showing the recedence of a glacier in Alaska over the last 60 odd years. NASA are pretty good actually. They've got a whole section of their website dedicated to climate change, because they know acutely that this is our only home, and the nearest home that might be useful or habitable is 25 trillion miles away, so we should probably keep this one serviceable. Another feedback loop is forest fires. There have been lots of those that have been happening in this country and in the Amazon recently. Fires release CO2, which is the main climate change gas that's released. The more that CO2 gets released, the temperatures increase, the likelihood of fires increase, and again you have this cycle: more fires, more CO2. So we're getting there. So this is permafrost. I don't know if you've heard about this, but this is permanently frozen soil or sediment and rock. It ranges from 1 metre thick to a kilometre thick, and it's generally in the northern hemisphere. It's estimated to hold around 1.5 billion tonnes of carbon stored as methane. So this is a problem, because this is a feedback loop, and it's one that we really have no control over once it starts. So you can see here on the right, this is images of gas coming up from a lake, and gas on the whiter image is a frozen lake. And on the image on the left, this is scientists lighting the methane as it comes out of the ice. It's known as the methane dragon because of the severe threat it represents. We're looking at methane is potentially 80 times more potent for the same amount than CO2, carbon dioxide. And that if this were to be released, or if all of it were to be released, then there would be nothing we can do to stop runaway climate change. It would start happening on its own. It would be unstoppable.
It is being released, isn't it?
It is being released. Yeah. But and also, as we're mentioning, that the poles tend to see climate change happening faster. So you can really see in some of the average temperatures, and there's been a few years on the trot where, like here in 2016, the average temperature would have been minus 25, but actually it was plus 0.4, which is a crazy change, and that's not going to help. Some ice is melting in places 30 years earlier than it was predicted to melt. So what we're seeing is that the reports and the models that have been produced tend to be a bit too they think we've got longer than we have. Now these feedback loops all link into one another and reach and push us towards tipping points and tipping cascades. Though it's not fully understood how all these link or how quickly or which bit's going to go first, but there's a fair understanding that once this is set in motion, there's not going to be a lot we can do about it. So we know now already, the government website will tell you this, we're not on target to meet the targets made in the Paris Agreement. We won't hit the 2-degree target, let alone the 1.5 degree one. We're more likely to hit 3 or 4 degrees by the end of the century, which would mean that the planet is essentially left uninhabitable, because as weather systems get pushed off kilter, torrential rain will mean, at the wrong time of year, will mean that food is harder to grow, people move. Anyway, I'm getting ahead of myself.
It's already happening anyway.
Yes, it's starting to happen, yeah. So this is a report saying that the predictions have been too conservative so far. Some other scientists would say we've got 5 years, some would say we've got 18 months to make a critical difference, and start building changes into the way we have our lives and what government does in terms of how we power the nation and how people are employed. And it's not just that, because the warmer air holds more water. This is a fact. And so we know we're going to get more intense rainfall. You know this if you're in planning, because more severe storms are now predicted. And the effect of that, other than crop failure and flooding, is for people to move. And there are widely varying estimates of how many people will move. This one here is talking about 140 million people within their country migrating. This one here is talking about 1.5 billion by 2050. This one here by 2 billion by 2100. But one thing we can be sure of is that it's not going to be a small amount of people. We've got 800 million people at risk of rising seas in coastal cities, because cities tend to be located near the coast because for trade, and you often have nuclear power stations there as well. If the ice in Greenland melts and Antarctica, then it's predicted that we will go over 0.5 metre of sea level rise. You'd be actually looking between 60 centimetres and 110 centimetres. Thanks for bearing with me, guys. So, as people move about, this is going to create friction. and potentially war. This is proven, according to this article. Here, the National Geographic is saying that this has been linked to the Syrian crisis. So specifically between 2006 and 2011, Syria had the worst drought for 900 years, according to NASA. It was far outside any natural climate cycle. 75% of farms failed, and 85% of the livestock died. There were 1.5 million starving rural Syrians forced to migrate to urban areas. They were hungry, they were homeless, and it wasn't long after that the uprising started. Now we know that that led to 2 million people making their way across Europe, and because we're a tribal species, we don't like strangers, we want to protect our lot, and there's nothing wrong with that, but that has led to some rather worrying political movements. We've seen the rise of the far right and the rise of populism, and the reality is that if climate change is left unchecked, you could have large swathes of the Middle East and Sub-Saharan Africa that are not habitable, and those people would come to Europe, and that would create a bit of an issue, let's say. So the IPCC, they talk about this in their 2018 report. So if there are high levels of public unrest, in their third scenario, high levels of public unrest and political destabilisation due to increasing climatic pressures, resulting in some countries becoming dysfunctional. So worst case scenario is you would have the fall of governments and societal breakdown. Just come open this door again. It's not just that, though. We're running out of water, as you know. Now, last time I saw Ian Macaulay speak, he mentioned this. It was at the Developer Day, I think in April or something. So this is a speech given by the CEO of the Environment Agency, Sir James Bevan. He talked about how our population is increasing, and with that our access to water will decrease. Ian recommended reading the entire speech, which I'll spare you, but I'll read you the last paragraph. There is a quote from Sylvia Earle, the distinguished marine biologist, which sums up in 12 words everything that's at stake here. It goes like this: no water, no life. No blue, no green, no ocean, no us. Let us resolve not to go there. But it's not just water either. The way we farm destroys ecosystems because we have monoculture, so just one species, leading to an eradication of forests and other wildernesses. And on top of that, we've got pesticide use, so insect population is under threat too. There's been a number of reports that have come out saying that we've seen a catastrophic decline in insects. Another one here. And they're not just looking at the number of species that are going extinct, but the numbers of each species, so the biomass, so the number of each animal within a species. So a study in Germany found that there was a 75% decline in the insects that were there in the space of 3 decades. The total mass of insects falling by 2.5% per year. It seems that you can't go a week without a report coming out on something like this. This one came out in May, and which looked at nature in general. 1 in 4 species are at risk of extinction.
It's
So
interesting what you said about biomass. I hadn't thought about it that way. If you think about an ecosystem, like the pyramid of an ecosystem, leaves, root, whatever, and then insects. If you knock one of those tiers out,
yeah,
we're just going to end up with that on top, aren't we?
yeah, that's really interesting. In fact, that's one of the slides which I didn't include, but I should have done obviously. So 10,000 years ago, there weren't giant rhinos. But what there were a lot more wild animals. We were just 1% of the mammals on the planet. Everything else was wild. What we've got now is 36% of the mammals are humans. 60% are livestock that we rear, for our protein, and then 4% are wild. So when we teach our kids in their flip books that the giraffes and this is an elephant, in reality those books should read cow, 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 pig, human, cow, because that's far more representative of what's out there and certainly where we're heading. Don't worry, we will get to the end. I feel a bit guilty, like I'm forcing bad news on you, but you came of your own volition.
That's reality.
It's reality, yeah. So we know that on top of all this, the way we farm removes nutrients from the soil. We don't allow those nutrients to be replaced. We remove the insects as well by ploughing. We've got 30 to 40 years worth of soil fertility left, according to Gove when he was Environment Minister, and that is equivalent to about 60 more harvests. When you go past that, then you can only grow food with petrochemical based fertilizers, which is okay, but it's not an ideal situation. Now, what's happened in the past, you might say? Thanks, Chris. Well, there have been 5 mass extinctions in Earth's history. Now, there's always extinctions going on, but when you have a cluster over a relatively short period of time, that's a mass extinction. Now, all of them have had climate change implicated with them. Even the one with the meteor impact that saw off the dinosaurs, it was the dust and the gases released from the impact that altered the climate and ultimately led to their demise. The Permian-Triassic extinction has had vast amounts of methane being released, has been linked to it. There's evidence that due to the volcanic activity, a lot of methane was released and it created runaway climate change. So people are starting to worry. They are doing things, but because we're busy people and we're with a short attention span and we want to buy stuff because that feels good, and we want to get drunk because that feels good, we don't see, or not enough attention is paid to this. It's certainly not positive and no one really wants to hear it, but 15,000 letters wrote open letters to humanity warning of irreversible damage. This was in 2017. And of course we're all aware of cyclones and hurricanes and those events which are affecting not really this country, but affecting a lot of people, millions of people. What have we seen here? Well, we've seen in 2004 there was a heat wave across Europe which killed 70,000 people, which sounds crazy. That's such a huge amount of people. If that was a terrorist attack, we'd be doing something about it, because we have evolved to deal with short-term threats, immediate threats. But something that's slow and gradual, drip-fed, just doesn't register. And so we don't have any kind of visceral fear response to it, because it's just, you look out the window and things are happening so slowly. We had 2014, the worst rainfall in 248 years. I actually went for a walk with Stu down that river in Wellies, and the water was nearly over the top of our boots on the footpath. There's a village that's due to be decommissioned because it's going to be just too expensive to build the flood defences. That people ultimately are going to have to move out. That's what we got here.
Is that on the coast, that village? Just
Yeah.
out of interest.
Yeah. So something Ian Macaulay raised, which that cattle were slaughtered early last year because they'd run out of feed. And then this year we've seen a shortage of cauliflower, which doesn't really matter because not many people eat cauliflower, but it was the crops here were wiped out by unexpected heavy rain, and the crops in Europe were wiped out by unexpected heat. So you couldn't buy it for love nor money, which frankly was just one food source, but it's a kind of an idea of the way things might go, or probably will go if we're not very careful.
There's been broccoli, I remember, and courgette, because we were teasing my sister-in-law who lives on those.
Broccoli and
And at
courgette,
one point there was, you couldn't get that, and the price went up, you couldn't get that, and the price went up, but it's little blips in a pattern, isn't it, that you can see
yeah.
increasing.
Yeah.
If that hit, like a thing we do all eat, then
Yeah.
you buy that.
Okay. So we're going to start moving on now to what the government's doing and what we can do. So you would think the government is on this and it's going to... I should have opened one in advance.
Oh, well, it's lunchtime.
Yeah, do it.
I'm hungry.
Go for it.
Carry on.
So you would think the government has got this, but it doesn't appear to, because there is no incentive for developers to build zero carbon homes. That's really efficient homes. That's gone. Solar power subsidies and incentives for people to install solar panels are gone.
Your political situation is a chaos. What do you expect that they will survive this?
So we'll try and have questions.
Yeah.
That's okay. And we actually subsidise the fossil industry, which is crazy. The fossil fuel industry, to the tune of £10.5 billion a year, which is the highest in the EU. And on top of that, you've got fracking and Heathrow airport expansion. So ultimately, however much recycling we do, however much cycling we do, if it's left to voluntary action, it won't be enough to do anything compared to the amount of emissions that will be released from new runway. And I think working, as most of you do, with developers, you know that people will always take the cheapest option if they can. We're, as I said earlier, we're quite short-sighted. And I'm sure that if asbestos wasn't banned, people would still be using it, because using it, you don't get it out of the packet and it doesn't suddenly burst into flames. There's a long gap between installing it and someone having a long and slow death. But thankfully the government have banned that, so that it's not an issue anymore in buildings. But we need them to do more, and perhaps ban other things. Who knows? So